Hello, in this video we will see mechanism of insulin secretion. We know that insulin is involved in control of blood glucose level. The higher the blood glucose, the more the insulin secretion. This insulin in turn decreases blood glucose level. But how exactly does increased blood glucose increase insulin secretion? That is what we will see in this video. Let's get started. Insulin is secreted from beta cells of pancreas. Before we understand secretion, let's quickly see what's the situation in cell under its resting condition. These cells have glucose transporter 2. Transport of glucose by GLUT2 is independent of insulin. Rather, it depends on blood glucose level. The higher the blood glucose, the more the glucose enters the cell. We also have mitochondria and other stuff involved in glucose metabolism. Next, we have ATP-sensitive potassium channels. Constitutively, these channels are open. Now, we know that for any cell, intracellular potassium concentration is higher than extracellular potassium concentration. Due to this concentration gradient, potassium continuously diffuses out through these channels. Loss of positively charged potassium makes the inside of the cell electronegative. This voltage in turn is important for voltage-sensitive calcium channels. At negative potential, these channels are closed. They open only when the cell depolarizes. Finally, we have preformed insulin stored in secretory vesicles. So this was the resting condition. Time to wake the cell up for insulin secretion. Let's say a person has taken energy-rich meal. This increases glucose level in the blood. This glucose enters the beta cells through glucose transporter 2. Metabolism of the glucose in the cell produces ATPs. Increased ATP level leads to closing of ATP-sensitive potassium channels. So potassium efflux decreases and it starts getting accumulated in the cell. As they are positively charged, the voltage approaches electropositivity. This depolarization causes opening of voltage-sensitive calcium channels. This allows calcium influx. Increased intracellular calcium finally triggers exocytosis of insulin-containing vesicles, and this results in the release of insulin into the blood. So this is how glucose causes insulin release. Now let's talk about the rate of insulin secretion. Release of insulin is not an all or none phenomenon. Rate of release, in fact, depends on blood glucose level. The more the blood glucose, the more intense the entire process, and ultimately, the more insulin is released. On the other hand, if blood glucose is low, the less intense the process and less insulin is released. I hope you now understand the mechanism of insulin release. That's it for this video. If you found this video helpful, please share it with your friends and colleagues too. And don't forget to subscribe Non-Stop Neuron, where learning medical concepts is as easy as watching cartoons. Thanks for watching. See you in next video.